Hello class, this is Mr. Henry here again with another video. Today we'll be looking at the second day's lesson on elimination. By watching this video, hopefully you have already done the homework for elimination day 1. Now in doing that, you probably saw equations that looked something like this. We have 2x, and then we have another equation that has either positive 2x or negative 2x. Right, and we need these to match, right? Whether they were both positive or one was positive or one was negative, we needed those to match in order to do elimination, which hopefully you noticed or hopefully realized that this isn't going to happen all the time, right? It's very rare that I'm going to have two equations with the same coefficient for each variable. Right, so today we're going to look at what's going to happen if I don't have those that match. And we'll see how that changes how we solve systems using elimination. But before we do that, I want to do a bit of a warm-up question. So take a look at this first one where our coefficients do match on y and solve this system of equations. Right, so here we have a positive 3y and a negative 3y. So hopefully you know whether you should add or subtract. Pause the video now, have a stab at this question, and then when you hit play, I will take up the question. Okay, in this question, I'm going to label the first equation equation 1 and the second equation equation 2. Since I have a positive 3y and a negative 3y, in order to eliminate y, I'm going to be adding. So I'm going to take equation 1 and add it to equation 2. Which will end up with 10x equals 6, right? 8 plus negative 2 will give us 6, which, if I rearrange, is 6 over 10, or reduced down to 3 over 5. So x is 3 over 5. Then I'm going to sub that into one of my equations. X equals 3 over 5. The coefficient on x here is a little lower, so I'm going to go with that one. We'll pick equation 1. So then I have 4 times 3 over 5 plus 3y equals 8. So 12 over 5 plus 3y equals 8. I need to make this have a common denominator when I move it over. So I'm going to end up with 3y, and to have a common denominator of 5, I'll multiply that by 5. So I have 40 over 5 minus 12 over 5. That gives me 28 over 5. And when I move the 3 over, I'm going to have 28 over 15. Right, so my point of intersection would be 3 over 5, 28 over 15. Right, if you're unsure of how we got that, maybe take a minute, go back to yesterday's lesson and get caught up. Today we're going to move on to some that are slightly more difficult than this. Okay, let's look at question B. In question B, I have 2x in one equation and 3x in the other equation. And I've got y in one equation and 2 in the other equation. Now let's just number these so we know which ones I'm talking about. So I don't have matching coefficients. I've got 2 and 3, and I've got 1 and 2, which is troubling because now I can't add or subtract to eliminate y or x. So I'm going to use another strategy here in order to make the coefficients match. Right, when we talked about solving equations with fractions, we talked about multiplying by a common denominator to get rid of fractions, right? So you should already know that we can multiply any equation by a number as long as we multiply every term in that equation by the same number. So look what happens when I take equation 1 and I multiply it by 2, I'll end up with 4x plus 2y equals 6. Right, so now I have matching coefficients. I've got 2y in equation 2, and I've got 2y in this equation. Since I've created a new equation, I'm going to number it as well. I'm going to call this equation 3. Now that I have two matching coefficients, I can do elimination. So let's say equation 3 minus equation 2. 4 minus 3, that's just x. Y is eliminated, and now I have 6 minus 6, so x equals 0. Right, and that's not anything special, right? That's not going to be no solutions or infinite solutions, right? X is just 0. Now I can sub x equals 0 into one of my equations, right? I could pick any of these three, right? But I'm going to pick the one that will be the easiest, right? It'll be the easiest in equation 1 because there's no coefficient on y, so that I won't have to divide by anything. If I subbed it in here, then I would end up having to divide by 2 later. So I'm going to take equation 1. So let's sub x equals 0 into 1. So 2 times 0 is just 0, which means I'm just going to have y equals 3. That was easy. So x is 0, y is 3, so my point of intersection is 0, 3. And then that one is done. Let's take a look at the next one. Actually, let's just summarize what we did here. We had two equations where the coefficients didn't match. We multiplied one of the equations so that we forced the coefficients to match, and then we can do our elimination. So let's look at the next one. In the next one, I've got 2x and 3x, which don't match, and I've got 5y and negative y, which also doesn't match. I also don't have these lining up, right? I have negative 8, my constant is on the left side of the equation, and here my constant is on the right side of the equation. So I'm just going to rewrite this top equation and move my constant over to the other side. Right, and then let's call that rearranged version of it equation 1. Let's call this other one equation 2. Now, in order to make coefficients match, I can't multiply 2 by anything to get 3 without creating fractions. But I can multiply negative 1 by 5 to make it negative 5. Right, I don't need to multiply it by negative 5 because then that would change the signs of everything, which would be more complicated than it needs to be. So I'm going to take equation 2 and multiply it by 5, which will give me 15x minus 5y equals 60. And let's call that equation 3. Okay, I've got 2x plus 5y in equation 1, and I've got 15x minus 5y in equation 3. Remember, when I have opposite signs, that means I need to add. So I'm going to take equation 1 and add it to equation 3. Which leaves me with 17x equals 68, which divides into 4. Now I'm going to sub x equals 4 into one of my equations. I'm going to sub it in to equation 2, because equation 2 doesn't have really a coefficient for y. For the same reason as last time, I'm choosing the easier equation. So I have 3 times 4 minus y equals 12. So 12 minus y equals 12. So obviously y has to be 0. So my point of intersection is 4, 0. So same strategy here. I multiplied one equation so that the coefficients matched, and then I was able to do elimination just like we did yesterday. Okay. Question D is a little more interesting than B and C, because let's look at the coefficients. I've got 2 and 5. There's nothing that I can multiply 2 by to get 5, and there's no integer that I can multiply 2 by to get 5, and same with 3. Can't multiply 3 by any whole number and get 4. So instead of multiplying one of these by some sort of fraction and getting weird coefficients, I'm going to take a different strategy here, and I'm going to multiply both of them. So let's call this equation 1, and let's call this equation 2. If I want to make the x coefficients match, I'm going to multiply the top one by 5, and I'm going to multiply the second one by 2. Right? If I multiply the top one by 5, I'm going to end up with 10x. If I multiply the bottom one by 2, I also end up with 10x. So let's take 1 times 5, which gives me 10x plus 15y equals 25. Let's call that equation 3. Then I'm going to take equation 2 and multiply that by 2, which will give me 10x plus 8y equals 32. And let's call that equation 4. So I came from having two equations where none of the coefficients matched to now having two equations where I do have coefficients that match. I did have to change both of them, so it was a little more work, but still pretty doable. I've got 10x and 10x. Both are positive, so I'm going to subtract. So let's take equation 3 and subtract equation 4, which gives me 7y equals negative 7. Oh, awesome. So y is negative 1. Okay, then I am going to sub y equals negative 1 into one of my equations. They all have coefficients on x. I'm going to pick the one that's got the smallest coefficient on x, so let's go with equation 1. So that gives me 2x plus 3 times negative 1 equals 5. So 2x equals 8. Right, negative 3, move that over, it's positive 3. So x is 4. So my point of intersection is 4, negative 1. Okay, so this one was slightly more challenging than the last one we did because of these coefficients. We had to multiply both equations to get matching coefficients. But once we had done that, the question is not any more harder than what we did yesterday. Right, we have 10x and 10x, so we are easily able to eliminate and get y and then use that to find x. Let's take a look at the next question. I want you guys to try and solve this one on your own, and then we'll take it up together. We saw a question like this yesterday, where we had some binomials here in brackets, and so if you remember from yesterday, all we had to do was expand those. So if you expand all of this, then you'll have two equations and you'll be able to see what you need to do to those equations to do elimination. So pause your video now, try the question, and then once you are done, hit play and watch me take up the question. These were the equations that I got. from the first equation, I got 4x minus y equals 9. Let's call that equation 1. Over here, I ended up with negative 3x minus 2y equals negative 16. So I just made everything positive instead of having everything being negative. Let's call that equation 2. So looking at my coefficients for x, I have 3 and 4. If I wanted to make those match, I would have to multiply one of these by 3 and the other one by 4. But I have negative y and positive 2, which means I only have to multiply one of my two equations. So let's take equation 1 and multiply that by 2. So that gives me 8x minus 2y equals 18. So now I have two equations that have 2y or negative 2y in them. Since they are opposite signs, I'm going to add the two equations. Let's call this equation I just came up with equation 3, and let's add equation 2 and 3 together. When I do that, I end up with 11x, the y's are eliminated, equals 18 plus 16, which is 34. And then divide by 11, I have 34 over 11 for x. Okay, then I'm going to sub that into one of my equations. So let's sub x equals 34 over 11 into one of my equations. That was really weird. Let's sub it into equation 1, because equation 1 doesn't really have a coefficient for y. So then I have 4 times 34 over 11 minus y equals 9. So that's 136 over 11. And I'm just going to, well, I'll leave these here, minus y equals 9. I need to make a common denominator. So instead of finding a common denominator for this, let's multiply everything by 11. Remember, you have the option to do either one. So this time, I feel like every other time I've found a common denominator. So this time, I'm going to multiply every term by 11. So that'll give me 136 minus, 11 y equals 99. Okay, I'm just going to move my 11y over to the other side and move my 99 over here. So 136 minus 99 equals 11y. So that is 37, and then when I divide it by 11, I have 37 over 11 equals y. So there is my point of intersection. 34 over 11, 37 over 11. So this one wasn't too much more tricky than ones we've done before. The only difference here is that we had to expand our equations before we could do some elimination, and then we had to multiply one of our equations by 2 so that we had matching coefficients. Let's look at the last one for today. For this one, I've got two fractions. And in this equation, I need to, well, I'm going to want to get rid of fractions so that things will be a lot easier, right? I need to have matching coefficients. Having matching coefficients when I'm dealing with fractions doesn't sound so awesome. So what I'm going to do in both cases is get rid of the fractions, right? Let's multiply each one by the lowest common denominator in that equation. so we can have some equations without any fractions. So let's take this first one. Lowest common denominator is 6. So multiply everything there by 6. This one, the lowest common denominator is 10. So I'm going to multiply everything by 10. So for my first equation, that leaves me with 6 over 3, or 2m, minus n equals 3, right, from that one. And then from this one, when I multiply by 2, I have 2m, 2m minus 3n, because the 10's cancel there, and half of 10 is 5. So let's call that equation 1, and this one equation 2. I already have matching coefficients here, so the rest of this problem should be pretty straightforward. I don't need to multiply either of my equations by anything. So I think what we should do at this point is, how about you pause the video now and try and solve for n and m, and then hit play and just confirm that you got the same answer as I did. Okay, so since I have matching coefficients here and they're both positive, I'm going to subtract. So let's take, let's jump up here, 1 minus 2. So, and just be careful here with your integers. Negative n minus negative 3n. That's going to be the same as negative n plus 3n, which is going to give me 2n. So 2n, and that equals negative 2. So n is just negative 1. And then I need to find m, so let's sub n equals negative 1 into equation, doesn't really matter here, so let's pick equation 1. So I have 2m minus negative 1 equals 3, so that's plus 1. But when I move it over to the other side, it'll become minus 1. So 3 minus 1, oops, 2m equals 2. So m is 1. So that one worked out pretty nicely. Let's just state our point of intersection. And since I've got variables n and m and n, so let's say mn equals 1, negative 1. And there we go. So to summarize, in this question, we just got rid of the fractions, made things a little simpler. We had matching coefficients already, so we didn't have to multiply again by anything. And then we did our regular elimination and got to our answer pretty easily. Just to wrap things up for today's lesson, basically the only new thing we did today was look at equations where the coefficients didn't already match. So as a note for you guys, and maybe I can try and move this message so it fits on the whole screen. Actually, don't think I can do that. So if the variable does not have the same coefficient in both equations, multiply one or both of the equations. So we looked at some today where we multiplied one equation, right? We were able to make the coefficients match by only multiplying one equation. But then there were some where we couldn't do that, so we had to multiply both of the equations. So I believe there was an example where we had to multiply one equation by 2 and multiply the other one by 5 so that we could make matching coefficients. Once you have matching coefficients, the same as yesterday, we just eliminate, find one variable, and use that to find the other. That is the end of today's lesson. I will be back in tomorrow, so I will see you guys tomorrow. Hopefully we have caught up on all three of these lessons and have done all of the homework by then. So I will see you tomorrow.